We're reviewing probability, and we're going to begin by defining sample space. The listing of all possible outcomes for an event is called the sample space. We use set notation, so for throwing an unbiased six-sided die, we simply list all the numbers. We use curly brackets and separate them with a comma. For tossing a coin, there's two possible outcomes, so the sample space would just be H, T. We normally use capital letters for coins and note the curly brackets and comma. For tossing two coins, there's four possibilities. In general, we use this formula to determine the probability of an event occurring. We are interested in the successful outcomes. So the probability of a successful event is the number of successful outcomes divided by the total number of possible outcomes. It's a fairly basic idea, but just remember one thing, that the probability of any event occurring must be less than or equal to 1. It's not possible to be more than 100% certain that an event will occur. To show how we can apply that formula, another simple example: what's the probability of rolling a 4 with a fair die? Fair means that the 6 possible outcomes are equally likely, so we have a sample space with 6 elements. We're interested in a 4, which is our event space. There's one successful outcome and 6 possible outcomes, so we write P in brackets 4 to represent the event we're interested in. We simply divide 1 by 6, and it's perfectly fine to leave your answer as a fraction. We need to be careful, noting that when we're listing a sample space, each element has to have an equal chance of occurring. In this example, a student is throwing an unbiased six-sided die, which is the same meaning as fair, meaning that each number is equally likely. But the student listed the sample space by lumping the odd possibilities and writing them as only a single element. So it looks like there are only 4 elements or 4 possibilities in the sample space, but there are actually 6. So it's not a suitable sample space, and the problem is that odd appears to have the same chance of occurring as each of the other elements individually, which is just incorrect. It's going to be very misleading and cause problems. So make sure that each of the elements in your sample space have an equal chance of occurring. Here's an interesting example. Find the probability of drawing a heart when a single card is selected from a standard pack of cards. Well, instead of listing all 52 cards, we can actually just list the suits. We're interested in drawing a heart, and there are 4 suits. So our sample space has 4 elements, and so in this example we can simply say the probability of drawing a heart is 1/4. The idea here is that each element in the sample space has an equal likelihood. Another example, a coin and die are tossed together. That means one after the other. Draw a suitable sample space, and then we've got to find some probabilities. Well, all we need to do is fill out the rest of the possibilities in the table. There are 12 possibilities altogether, 6 following a head and 6 following a tail. So the probability of a head followed by a 6, well, there's only one outcome in 12 that will give a head followed by a 6. A tail followed by an even number, well, there are 3 possible outcomes, 3 successful outcomes out of 12, so the probability is 3/12, which reduces to 1/4. Even a simple table can take a while to list out, so sometimes it's better to use a grid diagram, and we'll also go on to review tree diagrams. Both of those are often more suitable than listing out a sample space using a table. In example 1, we've got 2 dice, one red and the other green, and they're rolled together. Now there's 36 outcomes, but instead of listing them all separately, we can use this nice grid diagram where each point on the grid represents one of the outcomes. So to find the probability of rolling 2 3s, there's only one point on the grid that corresponds to 2 3s. So that means there's one chance in 36. In part B, what's the probability of rolling a red and a green die together and arriving at a sum of 5? So we look for the possibilities, the successful outcomes that would give 5, and that would be a 1 and a 4, so that's this point on the grid, or a 4 and a 1. We can also roll a 3 and a 2, or a 2 and a 3, and those are along that same diagonal. So there's 4 chances in 36, which reduces to 1 chance in 9.